In this lecture, we will be discussing about the helium neon laser, and let's discuss the few important points. So this was the first successful gas laser created by manufactured by Elizabeth and their teammates. Second point, if you see, so it is the gas lasers, okay, mainly helium and neon inert gases we have used over here. An important point over here is why it is different from the solid, because the atoms in this gases, they are characterized by the sharp energy levels compared to those in the solids, because we are knowing that in the case of solids the energy levels are very nearby, and that forms a compact or let's say a band kind of structure in the energy levels, and that is why the optical pumping is useful in the case of solid. But if you go for the gas lasers or the liquid lasers, then one can generally prefers the electrical discharge pumping to lift the particles or the atoms from the ground state to the upper state. Now coming to the working. So working is also very simple, but before working we have to understand few important points. Like here, so you see the actual lasing atoms are the neon, okay, and helium is used basically for the selective pumping of the upper level laser level of the neon. Now why I'm saying is because if you look at it out in this setup, the helium is in the majority, okay, and compared to the neon. So basically 10 times helium and 1 time is neon, something like this vector they are using in this setup. And you see when you pass the electric discharge to the gas, so the electrons which are accelerated down the tube collide with the helium, because heliums are in the larger quantity compared to the neon and neon atoms, right? But then the purpose of this, they excite them to the higher energy levels whenever you supply the electric discharge. And here again they have given some data of all such things, the energy levels, lifetime, etc. We'll discuss all such again in the case of energy level diagram. Again in this, the similar things they have given over here. So actually that collision process is going to be happen between this helium excited level particles and the neon ground level particles, ground level atoms. So that is how by the collision method they will be transferring the energy to the neon's energy level. So let me come to the energy level diagram, then we can have more good understanding. So here is the energy level diagram. Okay, one can see this scale also. So this is on the increasing scale. Okay, energy is increasing. Energy right now we have noted in the electron volt. Here is the helium ground level. Here is the neon ground level. So you see the energy levels also. So suppose this ground level I can denote with, let's say, F1. Here it is F2 and then F3. Again you see this is the same excited state, but actually split it into two parts because of the spin component. So that's why we are seeing this 2 1s, 2 3s. Similarly over here this is the ground level, and this you can call it as the E1 also. 1 minute. So this you can call it as the E1, E1 here. Then this will be the E2, then E3, E4, E5, and E6. So of course E6 is having the larger energy compared to E5 and all others. So that is how one can define the energy levels for neon and for helium also. And more such details also we are going to cover it. But before that, have a look over here in this part.
So anyway, I was discussing this one. So what I told you is the requirement of this one. Okay, at which particular amount of pressure you need to fill helium and neon inside the discharge tube. So that is 1 torr for helium, 0.1 torr for the neon. And if you look at, this is the criteria, okay, that 1 torr is nothing but equivalent to the 1 mm of Hg. Okay, this is the general unit which we are using. And now you see carefully, these are the excited levels of helium. Let me annotate it also. Okay, so this is the ground level of helium. This is the ground level for neon. And you look at, let me change the color also. And here is the excited one. Okay, so these are the excited states and possible excited states. Okay, so and these are the remaining one for the neon also, 1s2, 2s2. So someone can use this naming, and you people are knowing that. Okay, one can write always like 1s2, okay, 2s2, 2p6, Okay, so just like that, you can write the energy levels. I hope you people are aware with that, how to write with that. Okay, I will explain everything. So you look at these are the energy levels. Okay, you can write for every element. So for helium, it will be up to 1s2. Okay, for others, it may go on like 1s2, 2s2, 2p6. Okay, and something like that. So remember, you see, because we are interested up to only this part. Okay, but apart from that, few other levels are also there. Okay, depends if it is getting excited, then it can go to the 3s. So one can write 3s2 also and something. Okay, so that is what people are writing over here in this terminology. And remember, yeah, these are the excited states, upper possible states one can write over here, ground level, and then this. So you look at, they have classified as f2 and f3. Okay, and somewhere on the left hand side you see the energy scale is also there. Okay, so approximately energy also they have given like somewhere with around 20 electron volt. You see this f2 f3 will be there. Okay, the upper excited level. And again, see, you don't need to go worry with this part. Okay, I will explain it to you later on, what is that, why they are writing 2 3s or something. Okay, but right now you consider that these are the f2 f3, these are the upper excited level of helium. Okay, later on I will discuss, because this is all related to the quantum physics part. Okay, spin degeneracy, etc. So all such things will discuss it. And at the same time, for the neon, you see the higher energy levels they have written down in this order. Okay, so suppose this is f1. Okay, f2 f3. Similarly, this will be your e1. Okay, e2 e3 e4 e5. You see, you numbers you see. So you have to just look at these numbers. Don't need to go confused with this. E2, E3, E4, E5, E6. If you remember carefully, if you see carefully, then these are in the increasing order. So E6 is having the highest energy compared to E5. Then E5 is having highest compared to E4, and like that you can place. So okay. So you can also place in a sequence, or you can place like this, so that one can clearly identify like what is happening between the levels. So I have written down like in this format. Here it is F1, F2, F3. Here I am writing E1, E2, E3, E4, E5, E6. So these are all the possible energy states. Okay, for the neon. Now, if you look at carefully,
Do we
yes,
have to remember this wavelength?
wavelength.
Yes. Do we have to
Yes,
remember?
yes, yes. Because these are the output they have received. Okay, so these are the standard basically. So you need to keep in mind, if you are going to change this output, if you change that number, okay, that means that that particular length is not of coming from this helium neon. So you have to be very careful while choosing the answer for helium neon as well as for the ruby laser. Okay, so ये आपको थोड़ा सा याद रखना पड़ेगा wavelength का. But that is also very simple. No need to worry. I will let you know how you can keep in mind. Okay, it's very simple. Now coming to this part, what happens? There is one more thing in this particular setup. Helium neon, around 90% is helium. Okay, and 10% of the amount is will be of neon. Okay, so 90 और 10 का जो रेशियो है वो आपके सिस्टम में. So 80% is helium, 90% or 10%, sorry, 90% is helium, and only 10% will be of neon. Now important thing is when you pass the electric discharge, okay, what happens because of that, since majority charge, yeah, majority particles will be of helium. Okay, so they are getting excited because numbers are more for helium compared to the neon, 90 and 10. So you can see, so when you pass the electric current through the discharge tube, okay, so these heliums are getting excited. Helium atoms are getting excited, and they will reach to this F2 and F3 states. Okay, depending on the state or possible energies, they can come to F2 or F3 level. Clear? And second thing, so basically this is your ground state for helium. 1s2 we are writing. Excited will be 2s2. So this is nothing but your 2s2 only. But based on the spin component, okay, so one can also classify this 2s2 also in 2-1s, 2-3s, which you see on the screen. So there is energy splitting again in 2s2. So one can, what you can write is, suppose this is your 2s2, then it is splitted into two level like this. One will be at lower energy, second will be at higher energy. So these are all the quantum phenomena you people may be knowing in coming semester or something. So that is how this splitting works. Okay, but actually this is 2s2, but after splitting you can see 2-1s as well as 2-3s. Okay, so that all, if you are interested, we'll discuss it separately, because it take a lot of time to discuss all such things. Okay, but at this moment you just keep in mind these are the two possible energy states for 2s2. Okay, 2 1s and 2 3s. So many I have represented with F2 and F3. So these are in the excited part, because when you supply the electric discharge, majority of the particles are getting the energy and they will reach to this F2 F3 level. Now important thing is neon numbers are in limited numbers, only 10% around in the system. So what will happen? These excited helium atoms which you see over here, they are going to interact with the ground level particles of neon. Remember how this particular system is working. These are the excited atoms or the particles of helium. They are going to interact with neon particles which are there in the ground state. Now what happens because of that? Okay, so they will transfer the energy. So they are colliding with the neon particles or neon atoms. So via collision they are transferring their energy to the nearest equivalent level. So you see, in the case of neon, I have plotted all such possible energy output. Okay, so you see this is 1s2. Okay, this one is the 1s2, 2s2, and then you go for the 2p6. Okay, 3s2, 3p6, and like that you can go on. Don't go with this naming. I will explain it to this also, why there is a difference in the naming. Okay, but you simply keep in mind this is your 1s2, this will be your 2s2, 2p6, 3s2, 3p6, and like that you can go on. Okay, so these particular energy levels, okay, these helium's excited energy levels, they are colliding with the neons particle which is in the ground state, and they are transferring the energy to the nearest equivalent level. So you see, if you draw this line, let me make it clear. So if you draw this line corresponding to this, then you see its nearest equivalent level is E6. Corresponding to this, the nearest equivalent level is E4. So that is how they will, these helium particles which are in the excited state via the collision process, they will transfer the energy to the neons particle. Okay, and neons ground level particle. So after colliding this energy, that ground level particle will come to this, absorbing this, they will come to this E4 and E6 level. Okay, now this time these energy levels of neons are going to participate in generating the laser light. Okay, so you see, as I said, there are several levels. Okay, but ये energy कहाँ transfer हुआ? जो उसके nearest equivalent पे होगा, there only, so that full energy can be transferred via the collision mechanism. And now look at here, as I said, it has to come down to the lower level immediately. Can you hear me properly?
Yes, sir.
Yes,
Yes, sir.
No, someone said no voice. Oh, anyway, so you look this side. So E6, E4, okay, these are the excited energy now for the neon. Okay, now when the energy is, I mean, when these particular excited atoms are getting down to the lower state, they will emit the laser light. So if it is emitting from E6 to E5 level, you see, okay, don't go with this P4, P2, P4, you will not understand at this moment. So directly you see E6 to E5. So you see this particular wavelength we are getting. This is the laser output, 3.391 micrometer. Why we are writing this very small? Why it is coming very small number over here? Because you see the energy level difference between E6 to E5. It's very small. So if energy level difference is small, then the wavelength will be large. And that is why you are getting the wavelength in micrometer. Okay. Second thing you see, E6 to E4. Just 1 minute.
ये E2 2s2 आएगा ना सर?
Okay, so here you see, yeah, actually some emergency came. Okay, some faculty have arrived over here. So no, you just look at here. I was discussing this part. So 3.391, okay, that is one particular wavelength. In the second set, you see when it is emitting from E6 to E3, okay, then also it is giving a wavelength corresponding to 633 nanometer. Now if you see carefully, okay, this part, this energy level difference between E6 to E3, okay, this E6 to E3 is large, energy level difference is large. That means you will get a smaller wavelength, and that is why you are getting the answer in terms of nanometer. Okay, there is another criteria. If it is E4 to E3, that is also possible. So if your excited atom will decay from E4 to E3, then also it is emitting a wavelength, which is this one. Okay, 1.152 micrometer. Okay, again, if you look at carefully, the energy level difference between E4 to E3 is in the middle range compared to E6 to E5 and E6 to E3. Okay, you can easily check it out, the energy level difference from the diagram. Okay, and that is why somewhere in the middle part we are getting this particular answer, 1.152 micrometer. Okay, so these are the three main outputs we are getting from the helium neon laser. But remember, you have to select your requirement. So as per your requirement, other two output can be suppressed. Okay, so आपको अगर visible का requirement है, see this is for the visible light, 633 nanometer red color basically. If you have the requirement of this one, then other two you need to suppress. Okay, because from system you can take only one output, so that आपका जो proper purpose है application से, that can be fulfilled with that output. Okay, so other two you need to suppress it. Yeah, E3 have more wavelength than E4. E3 where it is. Okay, so you need to see the energy level difference. If it is from E6 to E3, okay, then see energy level difference is large, and that is why if energy difference is large, that means the wavelength is smaller. So you are getting a small number, 633 nanometer. But at the same time, if you see E4 to E3, this energy level difference is small compared to this one, E6 to E3, and that is why you are getting a larger wavelength compared to that. Okay, so that's how I told you that from the diagram, the energy level is very important to understand. Okay, so when you write into the exam, it has to be very clear why I am writing 633 over here only, why this number will be here. So no need to remember, you just need to look at the energy level difference. If difference is large, wavelength will be less. Okay, if difference is less, wavelength will be large. So like that you can easily place the numbers. Okay, and now coming to the query part, people may have some doubt. Yeah, we'll move from F3 to E6. So see, basically what is happening is this excited particles of helium, they are colliding with the neon particles and they are transferring the energy to the nearest possible state. Okay, almost 100% you see that they are transferring the output to the this E6 particles, E6 level. Okay, so basically these are the energy transfer mechanisms, and how to understand, let me give you an example, energy transfer, how it works. So basically when you provide it, okay, suppose if matches, energy levels are matches, okay, this is basically energy transfer. So the maximum energy transfer will be possible only when their energy levels are matching with each other. Okay, again let me take an example. Suppose if I want to deliver some content to you people, okay, then the level at which I am and the level at which you are, okay, if both are matching, then the energy transfer will be perfect. Are you getting that? If there is a mismatch from any side, either from my side or from your side, if energy levels or if our levels are mismatching, then whatever of the amount I will try to transfer to you people, or whatever the knowledge I want to transfer to you people, okay, it may not be perfect if there is a mismatch in the level of understanding. So that is why the best possible result one can get when the energy levels or the understanding levels are matching with each other. So then only the maximum knowledge transfer or the maximum power transfer can be possible. That's how, that is why we have considered the E6 and E4 only compared to E5, E3. Why? Because they are at the almost same level. So this is 4-level system. This is
Sir.
4-level system. Yes.
This helium plus is the maximum excited state of this helium.
Yes.
Then neon should be at the higher position, no, sir, than helium because it is small.
Higher in the sense, see, these are the ground state, as I said, these are the ground state up to, you can write 1s to 2s to 2p6. Okay, and then you need to write the possible energy states for neon. So possible क्या होगा उसके बाद 3s to 3p6, like तो अगर मैं देखूं देन these particular excited levels of helium they are matching with the excited levels of neon. तो अगर वो वहां पे इंटरेक्ट करता है ग्राउंड लेवल का, then it will transfer the energy and coming to the excited levels of neon particles. Are you getting that? Still any doubt?
Yes, sir, I did understand.
No, what I am saying is already you have excited the helium particles. Okay, so they are having this, let's say around 20 electron volt, you see, as you see on the screen. At the other time you see the neon levels. Okay, ground level it is like 1s2. So let me write it down again, just 1 minute. So this is your 1s2. Okay, this is your 2s2. Okay, this is your 2p6, then 3s2, 3p6. Don't go with these wordings, these namings you don't go, क्योंकि ये थोड़ा सा different scale है. I will let you know also why someone or this author has explained this scale. This is slightly different, and let me tell you that what is the difference between this. You people are knowing that if you follow that Avau principle, okay, so then you see it is following a pattern like this. If you remember this one, okay, that Avau principle, okay, so according to that if you go, okay, then 3p6 has to be larger energy compared to 3p4, or let's say 3p has to be larger energy compared to 3s.
Yes.
Agree with that, right? But here you see in this diagram, here in this diagram you see 3s is having higher energy compared to this 3p. Is it possible?
No.
No, not possible. But here it seems to be possible on the circuit diagram. Why? Because this scale itself they have considered on some different platform. I mean, scale जो है ना मेरा वो proper, I mean proper in the sense it is some different standard it is following. That's why you see the differences over here in the scale. 3s2 is having larger energy compared to 3p4, and that is why I told you rather than going to the this scale, you can just follow your own the previous one like 1s2, okay, then 2s2, this is 2p6, this is 3s2, 3p6, and this is 4s2. और आगे भी होगा तो 3d10 भी आएगा. So these are the possible energy states for the neon excited states. Okay, now what happens is when you give energy, I mean when you supply the electric discharge, these helium particles are getting energy and reaching to these levels. Okay, here this energy will be very high in this particular energy level. Now these excited particles of helium, they are interacting with the ground level particles of neon. Now you see ground level will be up to this much only, 1s2, 2s2, 2p6. Okay, these are the empty states, but remember these empty states are matching. If you go high, these empty states are matching well within this particular energy level. So what happens, these particular particles when it interacts with this, okay, so it will transfer the energy to this energy corresponding energy level only, because their levels are almost at the same energy. You see that levels, this one as well as this one at almost same energy, this level and this level is almost same energy. So when the energy levels are matching, they will transfer the 100% amount or 100% of excited energy to the neon particle. Why we are transferring, why we are giving to the neon? Because ultimately neons particles or neon so energy levels are participating in this process. Okay, so neon के लेवल से ही आपको लेजर लाइट एमिट होगा, ना कि हीलियम का. हीलियम का रोल क्या है, इजीली मैं उसको एक्साइट कर सकता हूं एंड देन इट कैन ट्रांसफर द एनर्जी टू द नियॉन पार्टिकल्स.
सर
Okay.
ये 6 से E5 के ट्रांजिशन में लेजर एमिट होगा ना?
यस, सो E6 से E5 में लाइट एमिट हो रहा है, लेजर लाइट. ओके, E6 से E3 में भी लाइट एमिट हो रहा है. E6 सॉरी 2 हो गया, फिर E4 से E3 में भी हो रहा है. बट हैव यू नोटिस्ड दैट E5 से E3 में नहीं हो रहा है, E5 से E4 में भी लाइट एमिट नहीं हो रहा है?
Yes.
There is also one reason for that. Okay, and that particular things we are knowing as a selection rule. So if you people are interested in more such things, because these are all such related quantum phenomena, okay, so quantum numbers etc, you have to be, I mean you must know the proper quantum numbers etc. So important thing is this one, okay, this particular naming, spin state, okay, and all such things, orbital angular momentum, all such things you have to keep in mind. That's why you see the differences over here.
Sir,
And selection, yes.
Sir, when we are saying that the helium atoms are interacting with the neon ground level atoms, and then
Yes.
the neon ground level atoms are going to E4 and E6, right? Like it's not directly from F2, F3 to E4, E6.
Because these are interacting with that only, then only it will reach to the excited state, right? But again, you
Yes.
see, energy transfer will be happen when levels are almost matching. So E4
Yes.
and E3 are having the same energy level, almost same, you see.
So
That's why
that
the
same
system
energy
will
level
be
will
there.
be transferred. So they will go to E4 and
Yes,
E3. Okay.
yes. ओके, दैट्स व्हाई वो E5 में भी नहीं जा रहा है ना E3 में जा रहा है, क्योंकि वो उसके एनर्जी लेवल से मैच नहीं कर रहा है. ओके, सो मैक्सिमम आउटपुट आपका ट्रांसफर कब होगा? जब एनर्जी लेवल्स आपके मैच होंगे. मिसमैच होगा तो आपका क्या होगा? एनर्जी ट्रांसफर तो होगा, लेकिन वो परफेक्ट नहीं होगा. सपोज 100% में अगर चाहता हूं कि एनर्जी ट्रांसफर हो, दैट 100% विल नॉट बी देयर. आर यू गेटिंग दैट? एक एग्जांपल और ले लो तो आपको क्लियर हो जाए. सपोज कि मेरे पास, मुझे आपको कोई कंटेंट आपको बताना है, राइट? मुझे आपको 4 लेवल समझाना है, बट मैंने आपको 4 लेवल के पहले 3 लेवल और उसके बारे में कुछ बताया ही नहीं है ना? तो अभी आप सीधे मान लो 2 लेवल से सीधे 4 लेवल पे जंप कर रहे हो अगर, तो आपको कंफ्यूजन होगा. क्यों? क्योंकि आपने पढ़ा 2 लेवल तक है और मैं आपको कंटेंट एक स्टेप जंप करके आगे बता रहा हूँ. तो थोड़ा बहुत तो समझ में आएगा, नो डाउट, लेकिन जो कंटिन्यूएंसी होनी चाहिए आपके सीक्वेंस में, कि वही 3 लेवल आया फिर 4 लेवल, आपका जो अंडरस्टैंडिंग है वो प्रॉपर नहीं होगा. थोड़ा बहुत तो आएगा समझ में, नो डाउट, लेकिन अगर मुझे प्रॉपर आपको समझाना है, प्रॉपर नॉलेज अगर आपको देना है, देन आई नीड टू मैच अवर लेवल्स. यानी आपने लास्ट टाइम कितना कवर किया, मैंने कहां तक कवर करवाया, एंड नाउ वी कैन स्टार्ट द न्यू कंटेंट फ्रॉम दैट मोमेंट ऑनवर्ड्स. सो दैट्स व्हाट वी आर डूइंग इट. ओके, एंड वही एक रीजन है जिसके लिए मैं आपको बोलता हूँ कि हमारे जो अंडरस्टैंडिंग का लेवल आपका है और जो मेरे समझाने का लेवल है वो मैच होना चाहिए. अगर वो मैच होता है तो हमारा आउटपुट 100% आएगा. बट अभी इफ इट इज मिसमैचिंग, किसी की भी साइड से या मेरी साइड से या आपकी साइड से, तो जो आउटपुट है वो 100 के बजाय 80, 90, या फिर आप डिपेंड कर लो कि आप और मैं कहाँ पर हूँ. ओके, सो आई एम नॉट सेइंग कि मैं हाई पे हूँ और आप लो पर हो, या वाइस वर्सा कि आप हाई पे हो और मैं लो पे हूँ. कहीं पे भी पॉसिबल है. बेट वेस्ट थिंग क्या है कि हमें अगर मैक्सिमम आउटपुट चाहिए तो हमारे लेवल्स मैच हो जाने चाहिए. एंड सेम थिंग इज हैपनिंग इन दिस ऑल्सो, कि अगर आपको मैक्सिमम आउटपुट निकालना है तो E6 से E4 में ही मैच होगा, बाकी में मैच नहीं होने वाला. ठीक है, आई होप दिस एग्जांपल विल क्लियर एवरीथिंग टू यू पीपल.
Yes, sir, it's clear.
Okay, fine. So now coming to this naming part. So these 3 output we are getting, you just keep in mind carefully. So basically these are in infrared. Okay, this micrometer part will be in the infrared. So basically 2 infrared output we are getting from helium neon, and 1 will be in the visible. So this will be the visible one, red color. Okay, now if you go to the naming part, as we are discussing this, we see something like 3s2 is higher than 3p4 or something. Yes.
सर जो है ना लेजर आउटपुट है वो तो सर है ना E3 से E2 में ही निकलेगा ना, क्योंकि अपन ने 4 लेवल सिस्टम में देखा था कि जब ग्राउंड स्टेट से हायर लेवल में है ना ट्रांजिशन होता है, फिर है ना नॉन रेडिएटिव पार्ट से है ना वो एनर्जी लेवल लो पे आता है थोड़ा.
See,
तो
see,
अभी
keep
ना
in just no, you are taking it wrong. See, you please understand the purpose. वो 4 लेवल केवल एक फिनोमिना था आपको समझाने के लिए, बट हेयर इट इज नॉट लाइक कि मैंने ये जो लिखा है आपको E1, E2, E3, E4 ये 4 लेवल को ही डिनोट कर रहा है. नो, क्लियर. एक पर्टिकुलर सिस्टम में अगर आप देखोगे देयर आर इनफाइनाइट नंबर ऑफ एनर्जी लेवल्स, राइट? तो वो जो 4 लेवल्स जो एक्चुअली पार्टिसिपेट कर रहे हैं ना, दैट यू हैव टू कंसीडर. सो यू डोंट गो विद दिस नेमिंग कि ये मेरा ग्राउंड लेवल ये E1 हो गया, ये मेरा E2 हो गया, ये E3, ये E4. तो 4 लेवल तो मेरे यही हो गए, तो ये तो 5, 6 यानी कि 6 लेवल वाला सिस्टम हो गया. तो इट इज नॉट लाइक दैट. वो एक नेमिंग था, एक कन्वेंशन था कि अगर आपका लेजर जनरेट होगा तो उसमें 4 लेवल्स जो है वो पार्टिसिपेट आपके करेंगे. नाउ विच 4 वो आपको चूज करना है डिपेंडिंग ऑन द मटेरियल. ओके, सो मेरे पास जो 4 लेवल है, ओके, वो मैं कंसिडर करूंगा एक ही मेरा ग्राउंड लेवल. ओके, बाकी के जो मेरे पास इंटरमीडिएटरी है स्टेट्स, वो मेरे ऑलमोस्ट सेम लेवल पे ही कंसिडर करूंगा मैं. यानी आपको केवल 4 एक्चुअल पॉसिबल लेवल्स देखने हैं जो उस पर्टिकुलर स्टेट में इन्वॉल्व है. आर यू गेटिंग दैट?
यस सर, समझ गए.
हाँ, तो ये नंबर से अगर इस लेवल से मैं जाऊं तो ये तो मेरा 6 लेवल सिस्टम हो जाएगा, और दूसरा भी मैं कोई हायर एटॉमिक नंबर वाला ले लूं तो मेरे पास पता नहीं, वो तो 7, 8, 9, 10 लेवल वाला सिस्टम हो जाएगा. सो इट इज नॉट लाइक दैट. विच आर द पार्टिसिपेटिंग वन, वी आर ओनली कंसिडरिंग दैट.
सर
यस.
सर E6 से E3 में लेजर इमिट हो रहा है, तो E6
हाँ.
से E4 में क्यों नहीं हो रहा?
हाँ, now we are coming to that part. Okay, so as I said that there is a factor called selection rule. Okay, so if you just search on the Google, even whenever we have some free time, I will also let you know. So according to that, okay, that let me write that. You all knowing are that the quantum numbers, right? N quantum numbers,
Sir.
principal quantum numbers. Okay, orbital angular momentum, Okay, spin
Yes.
quantum numbers. So all you are knowing, right? N, L, M, something. So important part is this L, orbital angular momentum, which we are writing with a small l. Okay, delta is the change in the small l. Now you look at, suppose if L equal to 0, then we are writing as S. Oh, sorry, L equal to 1. We are writing as a S orbital. Okay, 2 hoga, then P orbital. Something like we can write.
Yes, sir.
Yes.
Yes, sir.
Okay, so now this particular delta L, okay, it has to be changed with plus minus 1. That means, yeah, these are the selections rules we are saying. Okay, let me explain. If your delta L value is changing with plus minus 1,
सर
then only, yes,
L equals to 0 मतलब S होगा ना.
yes. I was waiting that someone can correct me also. So L equal to 0 S, L equal to 1 for P, L equal to 2 for D, and like that 3 for F, like that you can go on. Okay, so now you see it. So you are correct, absolutely. So now you look at here. No, just check it out one. Now you look this side. This particular thing E6 I have denoted with 3s2. Okay, E4 I have denoted with 2s2. So can you see the L value? L value is same. Can you see over here? Let me remove it out. Let's see. You are talking about E6 and E4, right? You look at number. Here is also S. Here is also S. So that means delta L, if you look at, that will be 0. So if this is the case, if delta L is 0, that means there will be no transitions is going to happen between that level. Okay, so always अगर आपको laser light emit होगा या कोई सा भी transitions होगा, for that what you required is delta L value has to be plus minus 1. Now check it for the other case. Let's say you have this E6 and E5. Okay, so E6 that means 3s2 and it is P. So L value is changing. Okay, if it is changing, that's why this laser light is emitting over here. Again you go for E to E3. So it is 3s2 and this is P4. Again L value is changing. Okay, and that's why we are getting the laser light from this. Now again you see E4 to E3. This is also S and this is also P. So L value is changing. That is why we are getting the laser light from that. Now look at carefully. E5 to E3. Let me remove it out everything. Now you see E5 to E3. यहाँ से भी आपका laser light emit नहीं हो रहा है. Why? Because you see this P as well as this P. So there is no change in the L value. And that is why you are not getting a light for the transition between E5 to E3. So basically, whenever this kind of cases are happening, delta L equal to 0. Okay, so we are saying it is a non-allowed transitions or something which is not allowed. Okay, और so transitions कब होगा जब delta L का जो value है वो plus minus 1 से आपका change होना चाहिए.
The delta L value for E6 to E5 will be +1 or -1.
Now you can change it out. See, किसके बीच का आप डिफरेंस लेते हो वो आपको देखना है. आप कहाँ से करते हैं? जनरली फ्रॉम अपर लेवल टू लोअर लेवल वी आर सीइंग. Okay, transitions. So upper level you see it is S, lower one is the P. Okay, so now you see what is happening. It's -1.
Okay, sir.
सर हीलियम से नियॉन में इलेक्ट्रॉन्स नहीं आने चाहिए ना, बिकॉज देयर इज नो डिफरेंस ऑफ एल.
कहाँ पर?
ये 20
हीलियम.
इलेक्ट्रॉन वाले वोल्ट पर ये जो
हाँ.
एनर्जी F2 F3 आपने बोला ना, दोनों में म्यूचुअल
हाँ.
ट्रांजिशन होगा, तो फिर नहीं
हाँ.
होना चाहिए ना कि डेल्टा एल वैल्यू तो उनका डिफरेंस तो 0 बन रहा है
ना, ये तो ट्रांसफर. सी दिस मैंने क्या बोला कि दोनों का एनर्जी लेवल बराबर है, तो ये कोलिजन के थ्रू एनर्जी ट्रांसफर कर रहे हैं, ट्रांसमिट नहीं कर रहे हैं. अगेन एमिट नहीं कर रहे हैं, ये एनर्जी ट्रांसफर कर रहे हैं. राइट, ये एनर्जी के लेवल पे ये एनर्जी को उसने एनर्जी ट्रांसफर किया कोलिजन करके. यहाँ से एमिशन प्रोसेस स्टार्ट हो रहा है. क्लियर?
ओके, आई गॉट.
या इज इट क्लियर नाउ? I hope this 3-level system, sorry, this 4-level system, helium neon is working properly.
Yes, sir.
Yes, sir.
Okay. Again, if you have doubt, yes, please ask. E3 to E2, yes, immediately आपको डीके करवाना है. ओके, यस, E3 to E2 वो आपका स्पॉन्टेनियस फोटोन के थ्रू उसको डीके करवाना है नंबर ऑफ पार्टिकल्स को. ओके, और फिर E2 से E1 में भी आपको यानी कि ग्राउंड लेवल पे लेके आना है. ओके, तो वो नॉन रेडिटिव होगा कि नहीं होगा वो डिपेंड करता है उसके बीच के टाइम इंटरवल पे, उस एनर्जी लेवल का कितना लाइफ टाइम है. दैट डिपेंड्स ऑन द कि वो स्पॉन्टेनियस में होगा लेकिन नॉन रेडिटिव होगा कि रेडिटिव होगा, दैट ऑल डिपेंड्स. So will it transit from E5 to E4? E5 to E4, now again you have to check it out, okay? Because E5 seems to be a broader level, okay? And E4 is very nearby to that, okay? So E5 to E4, there will be less chances because what happens is here the particles are coming from the upper excited level E6 to E4. Same way, these are the second energy level E4 to E3. So basically these are more excited or more number of particles are having. So that's why the transitions are happening from this only. E5 is comparatively less number of particles. That's why it is not, you see E5 to E4 is not there. Okay. So I hope it is clear. Now few more things you want to discuss, but I hope you people are aware with that. Okay. So let me just quickly go through the properties. And this is the scale we are following. Let me just move it one. Yeah. So you see this scale, just in 1 minute. You took it out. So this was the consideration. Ground state 1:2:2 2p6 for neon. So they have written as a ground state. But whenever it goes to the excited state 3s1, then that excited state they have represented with 1s. And that is why we see the difference in the scale. Okay, normally जो आपने पढ़ा है 12th में and whichever you see just now, there is a difference. So this is the main reason. And then you see 3p1. So they are writing as 2p. Instead of 3p, they are writing as 2p because they are following this particular notation, Paschen. Okay. So this is not the general one which you have gone through in the earlier classes. This is the Paschen notation. According to that, the ground level we are writing as the ground state, but the first excited state 3s1 we are writing as 1s. But in actual one, what we are writing is ground state always we are denoting with 1s. But in the Paschen case, the first excited state we are denoting with 1s, and then that sequence will go on 1s, 2p, 2s, 3p, 3s, and that is the reason you see the differences in the energy levels. Okay, so that all depends on the scales. Okay, so that is why whenever you write something into the exam or wherever, you have to clarify the things कि मेरा जो scale है वो किस particular notation पे काम कर रहा है, Paschen का है या फिर normal जो scale है आपका, that is working. Okay, so I hope this is clear to you people. Just one more thing is there, that is let me go through with that. Yeah, can you see that also?
Yes, sir.
Yes, sir.
Okay, just in 1 or 2 minutes I will cover it up. So characteristics of laser light. So one is the coherence, you see. Okay, coherence I told you people are knowing with that also. Same frequency, same phase almost, a constant phase difference. So that we are saying as a coherence wave. And this is the formula for coherence length. L is the length, C is the speed of light, delta T is the time difference. Okay, and you see the coherency, it is in the order of few kilometers. So that much high coherency you will get in the laser beam. Then you go further. This is the second property, that is the directionality. Okay, and now you people are knowing that what is the main thing which is responsible for that. So that alignment of the mirror, and that is why you see that we are getting with the help of optical resonator. Okay, so light will emit only in one direction. Okay, because of this setup only which we have done in the optical resonator. So because of that we are getting this. In the third, divergence. So you see this divergence also. So normal source से अगर आप देखोगे, then the divergence is very large, highly divergent. But if you compare to the laser beam, you see the divergence of laser beam is very small. Okay, and that divergence or the angular spread is given by this formula 1.22 multiplied by lambda upon d. What is d? D is the diameter of the front mirror. What is front mirror? The mirror from which you are taking the laser signal output. Okay, so that mirror we are taking as a d. I mean that mirror diameter you have to consider as a d for this. Okay, then intensity. Again, you know that this intensity also we are getting very high with the help of optical resonator. Okay, so all such things I have discussed over here, nothing to worry with that. Let me go through the next. Monochromatic. Okay, so you see the light someone was asking earlier also what is the range. So you see light from normal monochromatic source spreads over a wavelength range of the interval one can see in the normal light. Okay, so monochromatic is not there because it's a large spread. But in case of laser light, you see laser light is highly monochromatic because you see the spread in the wavelength, it is less than 10 angstrom. यानी कि इसका spread है वो काफी कम, तो जितना कम स्प्रेड होगा उतना ज्यादा मोनोक्रोमेटिक आपका लाइट होगा. सो दैट इज व्हाई वी आर यूजिंग दिस. Okay, so that's it from this side. Now coming to the last applications. So now you people are knowing there are several places. Okay, cutting, welding. Okay, hologram. So hologram में हम लोग helium neon use करते हैं. So keep in mind, hologram जो आपका होगा next वाला topic, उसमें हम लोग जो light source, laser source use करेंगे, that will be your helium neon. Okay, so and similarly there are various things you can find out the applications part. Okay, cutting में कैसे होता है, welding में कैसे होता है. I have just given you an idea. Same way there are technology called LIDAR, LIDAR, light detection वाले में भी हम लोग करते हैं, like laser guided force, laser range force, whatever. So this laser light is applicable in that also. So just go through that, you can find out more such applications because these applications are going on continuously. There are so many.